All right, guys. Happy Thursday. Welcome back again to another session. We're still going through this book. We're doing a good job. We're doing some tracking. So we are still on chapter 8. Chapter 8's a big chapter. Again, chapter 8 is titled Implementing Ethernet Virtual LANs. And this is titled from the Cisco CCNA 200-301 official certification guide book. Okay. I actually purchased the library. I really recommend you guys to purchase the library if you can from Cisco Press. Um, let's go ahead and go over today. We're going to go ahead and touch on a few things, right? We're going to try to end this chapter today. But today we are touching on troubleshooting VLANs and VLAN trunks. Okay. So as you guys can see on the screen, they got a couple of steps. After rereading it a few times during the day yesterday and today, and putting it to use with some labs, this 5-step process is a great way to do some checks, verify a few things, and to do some troubleshooting. Okay, let's go over it. All right. So step one, right? Confirm that the correct access VLANs have been assigned. Okay. Um, Step two, confirm that all VLANs are both defined and active. Okay, this is very important. Step three, check the allowed VLANs list on both ends of a trunk to ensure that all VLANs intended to be used are included. All right. Step four, check for incorrect trunk configuration settings that result in one switch operating as a trunk with the neighboring switch not operating as a trunk. Okay. I'm sure you guys remember that when we spoke about dynamic trunking protocol or what have you. Okay. And static trunk configuration. Okay. Check the native VLAN settings on both ends of the trunk to ensure the settings match. Okay. This is, I have no shame in telling you guys, I've made so many mistakes configuring, standing up some switches, right, for a switch refresh. Okay, switch refresh being we would replace switches that are in our environment that are end of life or end of support. Okay, dude, it is very important to define that. Okay, um, so that's a big thing. So let's go ahead and move forward, and we're gonna go ahead and touch on a few of these steps. Okay, all right. So first things first, here's some verification commands. Right, um, we have. Let me go ahead and get my handy dandy pencil. We have the show VLAN brief, okay, or just the show VLAN. Show VLAN brief, a little bit better, but again, you get different results. But again, the goal is you want to go ahead and see VLANs, right? So, what does show VLAN brief and show VLAN do, right? It lists each VLAN and all interfaces assigned to that VLAN, okay? But does not include operational trunks. So if you want to see, VLANs that are included on a trunk, of course, you have to do show interfaces trunk, okay, which was covered in two videos ago, two sections ago, okay. But of course, whenever we do the show VLAN brief, it's going to show us all access ports associated with the VLAN, okay. Show VLAN ID and then the number, right? It lists both access and trunk ports in a VLAN, okay? A little bit more detailed. I would say go ahead and use that if you don't want to type in two commands. Um, but yeah, this is a useful command. Show interfaces status. As you guys saw before, and we can go ahead and review that. Show interfaces status on ports operating as access ports. It lists the access VLAN, and on ports operating has trunk ports. It lists the word trunk. Okay. All right, and I'm sure you guys remember that section where we did the show interfaces status or the show interface um, gigabit or whatever the name of the interface is, interface number, and then the status. It'll go ahead and show us, hey, what is the administrative configuration of that port, right? You'll see static access, and what is the operating status of that port, of course. You'll see trunk or static access, okay? All right. And of course, I jumped ahead. So show interfaces type and then switch port. Exactly what I just said. this is what we'll see. It identifies the interfaces, access VLAN and voice VLAN, plus the configured and operational mode access or trunk. Very useful command. You can get a quick glimpse of, hey, is it a trunk or access port? Instead of doing a show VLAN brief, or show interface trunk, or show interface status, it'll tell you real quick, right, if it's an access port or a trunk. Okay. Um, of course, last but not least, show MAC address table. It lists MAC address table entries, including the associated VLAN. Very important, very helpful. So keep that in mind. Again, this table is a key topic for the exam, and for your studies. It's a key topic because on the exam, all right, you will be tested. You may be given a simulation to go ahead and type in some of these verification commands to get the answer to the question. So whenever you guys get a chance, if you guys are a part of maybe Neil Anderson's course, or David Bomble's, and you get his labs, practice as much as you can or build your own labs with a lot of these verification commands and understand what it does. Okay. All right, let's go ahead and keep moving forward. All right, so the next section we're going to talk about access VLANs, undefined or disabled. Okay, so real quick, right? By default, right? Switches do not forward frames for VLANs that are not known. Okay, why? Well, they're not going to forward, frames for VLANs that aren't known because it's not configured, right? Or if we're using VLAN trunking protocol, right, it hasn't been configured on the trunk, right? It hasn't been propagated down to the other switches that are using VLAN trunking protocol, right? Or, right, the VLAN is known, but it's disabled. Maybe you shut down the VLAN. Yes, you are able to shut down the VLAN so that it is not operational. Okay? So, as you guys can see, right? You guys can see on, and let me go ahead and get my pencil. Okay, I think Don was trying to join, but he timed out. Oh, there he goes. Okay, so as you guys can see, right, we have, right, some of the things that we were speaking about, right? We have right here, right, we have switch one. Uh-oh, we got some people trying to join. We have switch one, right? And we have, a no shutdown VLAN 10, right? And of course, we have a shutdown VLAN 20 command, right? And of course, we got a VLAN 30, no shutdown, VLAN 40, shutdown. Okay. All these VLANs, right, are configured on the switch. But for the ones that are shut down, and I want you guys to understand, the ones that are shut down, VLANs, what is it? VLANs 40 and VLANs 20. They can't pass traffic. They are not going to pass frames. So you're disabling the VLAN, and you're probably wondering, hey, why isn't traffic passing for X, Y, and Z ports, right, that are in this VLAN? Well, you shut down the VLAN. Okay, so that's why it's not passing no traffic. Okay, so that is a possible thing, right? Outside of this, as to why maybe traffic isn't passing for a specific VLAN, maybe you don't have the VLANs configured on that switch. Okay, so you need to either A, manually, as the administrator, configure the VLANs, right? Configure that broadcast domain. Or if you're an administrator that's using VLAN trunking protocol, VTP, make sure it has the proper configuration, has the slave VTP switch so that it can get the correct configuration from the master VTP switch and learn all the VLANs. Okay. Again, guys, VTP is not on the CCNA exam, but it's good to learn about just so you're aware of the technology. Okay. And I'll make sure if I don't, of course, because I forget. If you guys, I want to go ahead and do a lab for you guys so you can see how VTP works. It's pretty great. I actually, whenever my time at Cisco, I had to troubleshoot I had to go ahead and troubleshoot for a client VTP. Took 15 minutes. Very proud of it. But this is just from, again, labbing up a lot of these protocols and labbing up a lot of these theories that were in the books. Okay. All right, let's keep going. All right. And of course, this is just a screenshot showing, of course, access port VLANs with the show interface status, right? When we use the show interface status command, right, we can see all of our ports, right? But we can also see, hey, it's in this VLAN, it's in that VLAN, it's a trunk, trunk, all right? Of course, duplex and speed. Now I want to say something here, right? Um, if you're using old code in your lab or you're on Packet Tracer, you may not see some of these columns, okay? So if you're able to get your hand on a Cisco 9K or a new switch, uh, or a new switch, it'll have this. It'll have all these columns. Some of the older switches will not. So just keep that in mind, guys. Okay. All right. So let's go ahead and talk about mismatch trunking operational states. Right. Of course, we've seen in a working state, right? Trunking, whenever you configure trunks, they can be configured correctly, right? So that both switches are trunking over that pipe, right? And it's working, right? But the same way that you can configure a trunk to correctly work, you can configure a trunk to incorrectly work, right? All right. So, of course, we talked about dynamic trunking protocol. We have misconfigurations on both sides. But if you statically configure this, right, we can go ahead and have one side, right? One side has a trunk, right? And one side, oh, it has an access port, as we see here in the operational mode. Okay, so make sure you guys review, go back and read chapter 8, and you test out in your lab, right, using dynamic trunking protocol, and you see what's the different combinations are. I'm not sure if you guys remember that table. I can go ahead and go back and show you guys. Where is it? There we go. All right. So if you guys remember this table, right, goes over the different combinations, right? If we're using DTP, right? If we're using DTP, hey, this is the combinations we're going to get, right? If we're using statically, configuring our trunks, configuring our access ports, right? Here's the combos that we're going to get. You guys need to drill this table into your memory. Lab it up multiple times so you can see the results that you see right here. Okay? All right, you need to know this for the exam. Okay? Let's keep going. All right. So take a side step into the book. Let's talk about this, right? Figure 814, right, shows the incorrect configuration along with which side trunks and which does not. The side that trunks, switch one in this case, enables trunking using the command, right? And I'll go ahead and take my pencil. Go ahead and get that. Switch one, right? Uh, enables trunking using the command switch port mode trunk. So we statically configure the trunk here, right? Um, and we also made sure, hope you guys can see as well, we disabled DTP, right? So there won't be no negotiations going on, okay? So if it's going to go ahead and receive, right, DTP messages from switch 2, right? What's going to happen is switch 2 is not going to become a trunk with switch 1, okay? Because I said, hey, don't send me any DTP messages because I won't accept them. I am statically configuring, right, this link to be a trunk. So I won't be able to accept your DTP messages. Switch 2 is sending them, right, over the pipe, right, in milliseconds. Hey, here's my DTP messages, here are my DTP messages, right? Right? Since they weren't able to negotiate, this is going to go ahead and default to an access port. So what does that mean? So what that means is with switch 1 being able to carry multiple VLANs, right, tagging that traffic, being sent over a trunk, right, VLAN 10, VLAN 20, VLAN 30, and VLAN 40. What's happening is it's going to go ahead and leave switch 1 and die, right? It's going to go ahead and die right at that port because that port, 10 gigabit 1/1/3 off of switch 2, is an access port. So with it being an access port, it is defined to be only assigned to one VLAN. Didn't negotiate with the other side. Okay. So this is an example of a misconfiguration. Okay. So we need to make sure that we always, right? If we have something set on one side, okay, if we're doing dynamic trunking configuration on one side, it needs to be on the other side as well. Okay. If we're doing static trunk configuration, it needs to be the same on the other side as well. Okay. And the big key here, right? We could have had just switch port mode trunk, but since we put switch port no negotiate, it's not going to receive those messages at all or even try to break them down. Okay. That's the key part here. We put in this command, switch port no negotiate. So you're telling it, hey, I don't want to hear any messages for DTP. Okay. All right. Let's go ahead and keep going. All right. So let's talk about um, the supported VLAN list on trunks. Okay. So whenever you do a show interface trunk, right, what you'll see is you'll see a lot of output, right? And a lot of that output, it'll show you all the VLANs that are allowed to pass traffic on that trunk. Okay. All right. So three things, right? That you need to understand about a supported VLAN list or an allowed VLAN list, right? The VLAN has not, whenever we do a show interface trunk, a couple of things we need to consider. The VLAN has not been removed from the allowed VLAN list on the trunk, right? So let's say we see a VLAN, right, on the show interface trunk command for a trunk that we have, right? And maybe we're like, hey, why is VLAN 7 on this trunk? We could have sworn it's not supposed to be. Well, it's in the allowed list. We didn't exclusively configure on the trunk what's allowed and what's not allowed to traverse the trunk. Okay. All right. And as you can see, the command to go ahead and do that is switch port trunk allowed VLAN. All right. The VLAN exists and is active on the local switch. Show VLAN. Okay. So that means if we didn't exclusively configure it, like stated earlier, right, and it's a VLAN on the switch, and we're just using the show interface trunk, right, on an interface, it's going to pass all the VLANs by default. Okay. Last but not least, the VLAN has not been VTP pruned, okay, from the trunk because the switch has disabled VTP. The trunk is in a STP forwarding state in that VLAN, right? Ooh, excuse me. What does that mean? That means, right, the VLAN not being VTP pruned, right, is meaning it's not getting any configuration from a VTP master switch to say, hey, this VLAN, these VLANs don't belong on your switch, or it does, based on the master switch. Because in a VTP topology, right, all switches, all slave switches, are getting VLAN configuration from the master VTP switch. If it hasn't been pruned or this switch is not part of the VTP topology, it's going to be on that trunk. Okay, right? And also, if that's not configured and it's not pruned via VTP, and we have VTP disabled, that VLAN that's configured on your switch will of course, it'll also be sending traffic for that VLAN over the trunk, right? And we can, of course, confirm, right, a show spanning tree, right? And of course, the VLAN that it is forwarding traffic, and of course, that interface, that trunk, is in a forwarding state. Okay. Again, all things that you guys can go ahead and confirm, right? Um, Here's an example of what I talked about, right? We have, hey, all VLANs on the trunk, right? VLANs 1 through 60. Those are what's passing. Okay. We also have VLANs allowed and active in the management domain, right? This is referencing VTP, right? VLANs 1 through 59. Okay. Right. And for some reason, right? For some reason, we have here VLANs in spanning tree forwarding state and not pruned. Also referencing VTP, right? It's in a forwarding state, and this is not pruned. So we're forwarding on VLANs 1 through 58. Okay. Again, misconfigurations can happen. You need to make sure and use a lot of these verification commands to make sure as to who, what, where, why, and how for forwarding frames, right, at a layer 2 level, right? Because again, we're still on layer 2. And then when we get to layer 3, um, why isn't those frames turning into packets, right? It first has to start at layer 2. Okay. All right. Let's go ahead and clear this and let's move on. Okay. Um, as you guys can see, right? This lays out that show interface trunk command, right? Right? That first section, VLANs allowed, VLANs 1 through 4094, right? Minus the 2 removed by the switch port trunk allowed command, so 4095, 4096. Okay? Second, right? VLANs allowed and active, the first list, minus VLANs not defined to the local switch, right? That is, there is not a VLAN global configuration command, or the switch has not learned of the VLAN via BTP, and also minus those VLANs in VLAN shutdown mode. Okay. Third, VLANs in spanning tree. The second list, minus VLANs in the spanning tree blocking state for that interface, and minus VLANs VTP pruned for that trunk. Okay. All right. So again, study this, read it, do some labs. I mean, labs until your eyes bleed. Okay. Make it second nature, right? Read this, read the theory. Okay. Um, as I told you guys, one thing that I've learned of course, whenever I was studying for my CCNA, my CCNP, you have to study continuously, okay, until your eyes bleed. All right, so you can um, understand a lot of this theory because it's a lot of theory. Okay, and of course, when you engage other engineers, they're going to ask you the same questions. Um, and unfortunately, there, if you become an engineer or a specialist or an associate, there are questions as a dumb questions in your field. Okay. So lab as much as you can, know your stuff. Okay. Let's go ahead and close out this chapter talking about this topic. Okay. So one of the big misconfigurations, and of course, I'm not too proud to go ahead and admit that I've made this mistake as well. A mismatched native VLAN on a trunk. Unfortunately, it is possible to set the native VLAN ID to different VLANs on either end of the trunk, right? You can go ahead and do that using the switchboard trunk, native VLAN, and of course the VLAN ID. If the native VLANs differ between two switches, the switches will cause frames set in the native VLAN to jump from one VLAN to another, okay? For example, if switch one, of course, let me get my pencil, right? If switch one, all right, switch one sends a frame using VLAN 1, right? Native VLAN 1. So that traffic isn't tagged, by the way, right? Anything in the native VLAN, it's not tagged. It's going untagged over the trunk, right? Because it is agreed that, hey, anything untagged, it's in the native VLAN. Okay. Right. So we have, right, we're sending a frame, switch one is sending a frame using native VLAN 1, right, on a trunk, right? So switch one isn't going to add that 802.1q tag, right? It's not, just like I said, right? And that's normal. That's how native VLAN works. When switch two receives it, the native VLAN here is VLAN 2, okay? Right? So how switch two receives it, it says, oh, so I received untagged traffic. So this must be for VLAN 2, okay? Right? And so now what's going to happen is switch 2 assumes that the frame is a part of switch two's configured native VLAN. If switch 2 has been configured to think that VLAN 2 is the native VLAN on that trunk, switch 2 will try to forward the received frame into VLAN 2. Okay. All right. Right. And now we're going to have that frame is going to go ahead and be, it's going to go from VLAN 1 to VLAN 2 within your topology. Now we have what we call VLAN hopping. Multiple scenarios we can go ahead and create that can be dangerous for your environment. Again, misconfigurations. And of course, if a lot of you guys that are learning about cybersecurity, one of the major things that cause security incidents is misconfiguration by administrators. So please know your stuff. Take your time. Lab as much as you can. Make it second nature to the point to where if I call you and I don't know, and I'm your tech, and I don't know, rather than switching, you can walk me through configuring something just by words. Okay. All right, guys. With that being said, clear that. We are done with the theory section in chapter 8. Okay. So Sunday, we're going to go ahead and cover the lab, right? And we're probably going to have multiple labs for this chapter. Okay. Um, but thanks again, guys, for joining, and you guys have a great day.
All right, thanks, Dave.
Thanks, David. Bye, guys.